Today we're going to tackle implicit differentiation. And implicit differentiation really uses the chain rule in order to find the derivative of a pretty complex function. Let's take a look at this guy. You see you got, let's try that again. You see you got a y over on the left side of the equal sign, you got a y over on the right side of the equal sign. And since this would be a really tough equation to actually solve for y, we got to use something called implicit differentiation. And it uses the acronym DOFT. So if we're going to find the derivative of this, we have got to do this. First of all, we are going to find the derivative, which sounds like we'd be done, but we're not. Derivative with respect to the variable x. Then what we have to do is we have to organize that derivative. And organize means x's on one side. Well, let's say this. Let's say y primed terms on the left. Instead of saying x terms, let's say non-y prime terms. On the right side of the equal sign. Then what we'll do is we will factor. We will factor out y. And finally, we will divide to get y primed alone. All right. So that's what we're going to do. Now, one thing that I want to make clear here is that if we're taking the derivative of x squared, what's the derivative of x squared? You're going to say 2x, right? And you're absolutely right, because you're taking the derivative with respect to x. X is the variable, that's what we're taking the derivative of. Now, what about y cubed? You'd probably think 3y squared. Well, that's the derivative with respect to y. If you are taking the derivative of y, what's the derivative of y? And if you said, well, the derivative of y is y primed, you're absolutely correct. But what's the derivative of y cubed? Well, I'm going to use the chain rule. And I'm going to find the derivative of y cubed with respect to the variable x. Well, let's see. Chain rule says that I've got to derivative of the outer, don't mess with the inner, so that's still a y. It's now to the second power, times the derivative of what's inside. And the derivative of what's inside that is the derivative of y with respect to x. Sometimes remember the other notations, dy, dx. So this, using the chain rule, is the derivative of y to the third. So, with that in mind, let's find the derivative of this x squared plus y cubed equals. All right, let's see. I am going to erase what's on my page. And I'm going to find the derivative. Well, let's see. We got 2x. Plus, now we already said the derivative of y cubed. We said that was 3y squared y prime equals, whoa. Now we're going to have to use a product rule. And what you'll find in most of just about all of the implicit differentiation problems, again, identified because you got y's on both sides of the equal sign, or it's very difficult to get y all by itself, you will have a product rule. So if I take the first, which is 3x, times the derivative of the second, and derivative of y is y primed, plus the second, which is y, times the derivative of the first, the derivative of 3x, that's what I get. And then the derivative of 9 is 0 because it is a constant, and I have taken the derivative with respect to x. Now let's organize this. Let's get all of our y primes on one side, our non-y primes on the other. This 3y squared y primed is going to stay over here on the left. This guy's got to come over because it's got a y prime, so I'll be subtracting 3xy primed in order to get it over to the left. On the right side of the equal sign, I've already got this 3y, but I better get this over there. So I have organized by getting all the y primes together on the left side. Now I'm going to factor out that y prime. And the other side, nothing to factor. It's good the way it is. And now, to get the y primed all by itself, I just got to divide both sides by this. And so I will know that y prime, the slope, the derivative, with respect to x, is going to be 3y minus 2x over 3y squared minus 3x. All right. That's all looking pretty good. So I'm going to move on. And the equation of the tangent at 3, 3. Now remember that y primed is equal to, now I got to try to remember this. What did we get? 3y minus 2x over 3y squared minus 3x. So if I'm going to write the equation of a line, the equation of a tangent line, I'll use point slope form. Y minus 3 equals slope times x minus 3. They didn't tell me which form of an equation of a line to use, so I'm using that. So let's see the slope. I got to put a 3 in for y, I got to put a 3 in for x. That's 9 minus 6 over, I think this is going to be 27 minus 9. I'm going to get 3 over 18, or 1/6. So if I've done everything correctly, that's what the equation of the tangent is going to be. Now, how would you ever know? Whoopsie, I'm sorry, I kind of jumped quickly there, but just checking out the bottom of the slide. How would you ever know if a tangent is horizontal? How would you ever know that this strange function have a horizontal tangent? And if you're thinking it's because the slope would be equal to 0, you're absolutely correct. Okay. Let's find y primed here. All right. Well, let's see. I got y's on both sides, looks like implicit differentiation. So I'm going to have derivative y primed equals. This guy here looks like a chain rule. Derivative of the outer, don't mess with the inner, times derivative of the inner. And what's the derivative of y squared? Again, you're thinking, so I've got to take derivative of the outer, 2. Don't mess with the inner, 2y to the first, times the derivative of what's inside, y primed. When I took this in college, this just baffled me. And the way I made sense out of it was I said, do I just take the derivative of this the way I normally would, call it 2y, and then multiply by y prime? The professor said, yeah, that's the way you do it. So maybe that's an easier way to remember it. Take the derivative of it just as you normally would, tack on a y prime. Now, in order to get my y primes all on one side, what I need to do first is I need to distribute this. I've got to say y primed is equal to negative 3 sine 3x plus y squared. Then I got to distribute here and say minus 2y y primed times the sine of 3x plus y squared. So in an effort to organize, I need to distribute first. And now the second part of organizing is let's get this guy over to the other side. So y primed plus 2y y primed sine equals negative 3 sine So organize is now done. Now, some people will factor and divide all at once. So if I factor and divide all at once, this is going to be y prime times 1 plus 2y sine Instead of writing all this out, what some people will do is they're going to kind of do that in their head, and they're just going to jump right down to saying y primed is equal to negative 3 sine 3x plus y squared over 1 plus 2y sine 3x plus y squared. All right. Now for number 9. Got a cotangent in it. And we said that isn't one that you need to know. So if you need to, go ahead and look that one up in your book. But use the chain rule to find out what y primed is equal to. Use implicit differentiation to figure out what y primed is equal to. Why don't you tackle it? I'll tackle it. And after we come back from a brief pause, let's see how we did. All right, I've shown my steps for derivative, organize, factor, divide. Keep in mind product rule. And again, a product rule here. Much like the last example, the organized step requires both a distribution and then the organizing of getting the y primes on the same side. If you've done that correctly, then you factor and you divide. And here's what you're going to get. Now, what's not so obvious here is that there is a common factor up on top. I could factor out negative y and call that negative y times 1 plus cosecant squared xy. And on the bottom, I could factor out an x. 1 plus cosecant squared xy, which factor out to be 1. And so the derivative of this function right here is merely the opposite of y divided by x. So that's pretty incredible. Very cool. Okay, final example. We got to find y double primed. This one doesn't look too bad. But finding y double primed has a little bit of a trick to it. So let's see. Derivative. Let's see, 3x squared. Here's that product rule. First, derivative of the second, derivative of y squared. Take the derivative as you normally would, tack on a y primed, plus the second, times the derivative of the first, and the derivative of the first is 1, equals 4x. Well, organized is pretty nice. This is the only y prime term there is. So 2x y primed equals this 4x. I'll have to subtract the 3x squared. I have to subtract the y squared. And then there's no factor step because there's only a single y prime term. So y primed is equal to this 4x minus 3x squared minus y squared over 2xy. So there's y primed, and that wasn't too bad. So now let's find y double primed. Well, the derivative of this side is y double primed. And it is equal to. Now I'm going to have to quotient rule this other side, and that's going to be a pain. I'm going to have to low d high 4 minus 6x minus 2y, and I'm just going to, for giggles here, make this a different color and call it y primed. There's low d high minus high. Well, high 4x minus 3x squared minus y squared. D low. Better use a product rule. First, 2x times the derivative of the second, which I'm going to call y prime, plus the second, which is y, times the derivative of the first, which is 2. All over low, low. Two xy squared. Okay, now you'll notice that I kind of highlighted those y primes. The reason I have highlighted the y primes is because when you write y double primed, you cannot write it in terms of y primed. You have to write y double primed in terms of x's and y's the same way that you wrote y primed in terms of nothing but x's and y's. Now, this would be very difficult if I had to multiply everything out. But you don't. Just show me that you understand it. If I'm going to write y double primed, here's what I got to do. I'm going to have this 2xy times this 4 minus this 6x minus this 2y times y primed. And so what I'm going to want you to do is to write y primed as 4x minus 3x squared minus y squared over 2xy. Again, we're not going to have to multiply that out, okay? Just show me that you know that you have to put that expression in for the y double primed. So your y double primed, you have to put it in for y primed, so that your y double primed is written in terms of nothing but x's and y's. Okay, now we're going to subtract this 4x minus 3x squared minus y squared times 2x, but instead of y primed, I'm going to write 4x minus 3x squared minus y squared over 2xy plus 2y, all divided 2xy being squared. No simplification beyond that. And to be honest with you, I don't think we're going to see one where the answer comes out quite this complicated. But that's what you have to do to find y double primed, is put your expression for y primed in place of wherever you initially have that y primed. So let's take advantage of an opportunity to practice this.